All right, so let's talk about short-term decision making. So what are short-term decisions? Well, the obvious answer is that they're decisions that are made by management that impact revenues and costs in the short term. However, we've got to remember that these short-term decisions often do have long-term impacts as well. So let's say you're making a short-term decision on whether or not you want to work with a vendor because they're giving you a good sales price on buying in bulk or whatever the case is. That could turn into a long-term relationship between you and that vendor. So we got to keep that in mind, that while these are short-term decisions and they have an immediate short-term impact, some of them may also have that long-term impact as well. So when we are talking about short-term decisions, we have to make some assumptions, okay? And when we consider these types, the assumptions that we make are as follows. And you're going to notice a trend here. So capacity is fixed. So you're not going to make any new buildings. You're not going to hire any new workers. Your physical capacity cannot be added. What that means is, so let's say you are a bottle manufacturer. You manufacture glass bottles for soda companies, beer companies, whatever the case is. And you cannot increase the number of glass bottles that you produce in this short term. Okay, so your capacity is fixed. Whatever your capacity is, it is fixed. The next one is the decision is ad hoc, meaning it's on demand. So you're not going to make these plans during your normal long-term planning phase that we talked about back in Chapter 1, Chapter 2, where we talked about, hey, we've got this strategic planning phase, and that phase is usually for the long haul, right? That's your 5 to 10 years. Sometimes you're making a 1-year plan. Whatever the case is, these decisions are not a part of that. These are on-demand decisions. They're that's why we're calling them short-term, right? They come up and you have to make a decision quickly about them. The next one is that you got to address them in a timely manner. Okay, so since they are coming about because of changes in the business environment, because there's a sale on something, let's say that you work with a manufacturer or a vendor and they know that they are going to be producing an updated version of a product. Let's say it's Doritos, right? Okay. The Doritos bags that we see now do not look like the Doritos bags that I saw when I was a kid. So they may offer, if Frito-Lay is changing the marketing, changing the branding on a Doritos bag, they may say, hey, we'll sell these older bags, the ones that are going out of style, so to speak. We'll sell these to you cheaper. We got to make that in a timely manner. We can't sit around and go, can we think about it for a couple weeks and then get back to you? Because what's going to happen is in that couple weeks, somebody else is probably going to jump on that decision. And we'll talk about what those opportunity costs are later. Okay. Then we got to realize that each decision is a unique decision in and of itself. Okay. So you've got to look at it as a distinct opportunity when you're doing your analysis, when you're building your model for it. Each one's got to be a distinct opportunity. And then finally, we're going to use decision-making models. These models are simply just representations of reality. So what we're going to be able to do is plug things in, and we'll see at the end of this chapter when we talk about our variables and changing the variables in our cost, volume, profit analysis. That's exactly what we're doing, is we're simply using a model to represent what could really happen. Okay. So the next thing we got to talk about is that cost, volume, profit analysis. If you remember back in Chapter 3, we talked about high-low volume, or excuse me, it's not high-low volume, but it's high-low analysis. And that was one model that we used. The cost, volume, profit analysis shows us how these costs, these revenues, profits, how they change in response to the volumes of goods and services provided. And we'll see that later in the chapter once again when we talk about changing these variables. What CVP is useful for is that it's useful for determining whether a product or enough of a product can be sold or purchased to cover the costs of purchasing or manufacturing that product. This will come into play when we look at our, do you make or buy decision? Do you accept or reject decision? That kind of thing. So it's really just useful for saying, okay, how much of this do we need to be able to cover our costs? Can also help you kind of determine the selling price needed if the quantities demanded can be estimated. So if we kind of have an idea of how many we might need, we can determine a selling price. Do we want to come in and make little profit in the beginning, but know that our costs are going to drop in the long run, and we'll turn more profit that way. This is just kind of the way we're going to determine selling price. So this is just like in Chapter 3 modeling. We have to identify things within the relevant range. If it's not in the relevant range, it is not valid. So those cost volume profit assumptions. When we are modeling our cost volume profit, we need to make the following assumptions. And again, you will notice a trend here. And that trend is that everything pretty much has to remain constant. So our selling price is going to remain constant regardless of the number of units sold, right? So we're not going to be giving discounts, for instance, if somebody buys in bulk from us, we're not going to give discounts. Variable cost per unit remains constant regardless of the volume sold, right? So our variable costs aren't going to drop based on higher production values. Fixed costs remain constant regardless of the volume produced or sold. Again, we're not going to change our fixed cost at all. Everything has to remain constant. And then if we're talking about manufacturing, the units that we produce equal the units that we sell. If we're talking about retailers, the units that we purchase are the units that we sell. So these assumptions can kind of look like they're limiting what we can do, but they really do provide enough realism within that relevant range that they provide a useful model. Okay. So let's talk about the break-even point. What is the break-even point? So the break-even point is simply when your total costs equal your total revenue. Okay, that's it. That just means we're going to make $0, we're going to lose $0. Okay, we are breaking even. Okay, so if you're looking at a graph, the break-even point is where the cost and revenue intersect, okay, where those two lines intersect. The graph for this is on page, let me look real quick so I can give you the right page here. Wrong chapter even. Sorry. Yeah, so page 101 in your textbook will show you kind of the CVP graph. And you can, the cost volume profit graph, and you can see the break-even point there. It's where your cost and your revenue lines intersect. You should be able to tell where your revenue line is and where your cost line is because of their y-intercept points. So remember that your revenue will intercept at 0 always. So when the total volume does exceed the break-even point, right? So your revenue exceeds the break-even point, the difference is profit, okay? The same thing is true when your revenue is below the break-even point. That is your loss, okay? So recall that we calculate total revenue by taking the selling price per unit and multiplying that times the number of units sold. Here I put it out in letters. This is how the book does it for us. So TR, total revenue, equals SP, or selling price, times Q, which is the quantity. You will notice, though, on our CVP graph that the x-axis is now units. Previously, we used the x-axis as activity, so instead of using x as our representative of that axis here, we're going to use Q instead to represent units. So just a repeat of that total revenue formula: selling price per unit times the number of units sold equals the total revenue. Now to find your total cost, you take your variable cost per unit and you multiply that times the number of units produced, and then you add in your fixed cost. That's going to give you total cost. So once we have that, now we can find our formula for profit. And we know that our profit is our total revenue minus total costs. That's the simple version, or we could split that out into your selling price times your quantity, total revenue, minus your variable cost times your quantity, minus your fixed costs equal your profit. Okay. Now, keep in mind we have to reduce our revenue by those fixed costs. So that's why that is a subtraction from subtraction by our fixed cost there. So once we have that information, once we know our profit, we can find our contribution margin per unit, and that's really important. And the contribution margin per unit is simply the portion of each dollar of sales that goes to contribute to fixed costs. So what is left to contribute to those fixed costs? And then once we can account for the fixed costs, we can find the contribution margin. So the contribution margin is simply your sales price less variable cost at any given activity level. And this is what we call the cost volume profit relationship. We derived this earlier, right? Your total revenues minus your total cost equals your profit. We can simplify that formula down because your selling price minus your variable cost ends up becoming your contribution margin. You multiply that times your quantity. You reduce that by your fixed cost. That gives you profit. We can simplify this down to simply say our units, the number of units, is our fixed cost plus our profit divided by our contribution margin. That is the simplest way to calculate that. That is the formula we are going to use in this class. That is the formula I would suggest that you use if you have all of the information you need. If you need to find one of those numbers, then you can use that formula at the top and simplify your way down. But most of the time, I would imagine we're going to get pretty clean version of this where we can just use this quantity equals fixed cost plus profit divided by contribution margin.